Okay guys, let's go over your homework for tonight. We've got 3 assignments, Chapter 5, Number 4, Chapter 5, Number 6, and Chapter 5, Number 7. Yes, I know there's no number 5. I just didn't like the questions, so I just decided no, I don't think so. All right, so let's start at the beginning. All right, so Chapter 5, Number 4. We'll start there. Now, I'm going to warn you ahead of time. I'm in my dining room and the dogs are out getting walked, but they could come home any minute, in which case we will get interrupted because they are loud and crazy. So just be warned. Just be warned. You can always just hope for it, right? Okay, so number 1, they give you a force, no value, of course, right? And then you're given mass 1, and there's an acceleration of 4 meters per second squared, or whatever your value is. And then they give you the same force, a second mass, and then a second acceleration, whatever your mass is. And the first thing they do is ask for a value of the ratio m1 to m2. So my suggestion, of course, would be to solve these, put them in a ratio. And in which case then, if m1 and m2 are combined, find their acceleration. Okay, so honestly, what I would do here is I would make up a value for f, and the easiest value I think to make up is the number 1. Solve for m, and then add them up, and then find the new acceleration. Mostly working with proportions, but I always do enjoy just making up numbers, and I work with the simplest numbers I possibly can to do that. Okay, your next question is about a nitrogen molecule, and it's rebounding off of a wall. You're given the initial velocity and the mass. And you're given the mass of your particle. And then it tells you how much time it takes for it to rebound off the wall. And the first thing is your average acceleration. Okay, what I'm going to remind you here is that acceleration is the change in velocity per unit time. However, watch out for the rebound. That's going to change direction, which means you're going to have to be careful about your positives and negatives, okay? They tell you that the opposite direction is your negative direction, so follow that lead when you put in your sign at the end. And then to do average force, it's just a very straightforward F equals ma. Okay, number 3. Number 3 seems a little tricky at first, but actually not that difficult. You're given 2 values for a position function, and the minute you get a function, you should be thinking to yourself, I need to use calculus for this. All right, so here are the functions that I've been given. And you're being asked to find the magnitude of the net force, and you're given a value for your time. So what you want to do is take the second derivative of this function, the second derivative of this function, and figure out what your accelerations are. So here we have 10t. My acceleration in the x direction is 10. Here I have 9t squared, so 18t for A. At this point, I'm going to plug in the time right there and get an actual numerical value for my acceleration. And then, of course, I have this one. Now, they're telling you that this one is in the x direction and this one is in the y direction. So obviously, you have a combined velocity total that you're going to need to use the Pythagorean theorem for. And then ultimately, you can just use F equals ma in order to find the net force. So that should be pretty straightforward. All right, your last one. Your last one is a classic problem of, tensions and ropes, and they've got this bag of cement here, and you've got your little values, theta 1, theta 2, and T1, T2, T3. Okay, they actually give you a whole bunch of stuff. Okay, so they tell you right away that the FG, they give you a value for that. Mine's 325 newtons. And then you're given the actual values of the angles. Mine are 50 degrees and 20 degrees. All right, and you're asked to find the tensions in the wires. Well, finding T3 should be incredibly obvious, I should hope. Once you've got your value for T3, keep in mind what you're going to want to do here, of course, is make some triangles out of it. And I'm going to go with the outside triangles just because they're easier to write. So my 50-degree angle comes down here, my 20-degree angle comes down here. So if this is T1 and this is T2, then this is going to be sine 50 T1. This one's going to be sine 20 T2. I already know the value of T3. heading down. Okay, now these are obviously not equal because you've got different angles here. And you've got two things pointing up, only one pointing down. So my suggestion, if you're stuck, work with left and right. These must be equal. These are my cosine pieces. Cosine 50 T1, cosine 50 T2. Those have to be equal to each other. And so it shouldn't take too much to get a ratio of T1 to T2. And then when you do your up equals down, you can substitute one into the other. So just to, oh, I wrote that wrong, didn't I? 20. Just to have you see what that looks like, just in case you're still like, what? All right, so T1 cosine 20 T2. So let's just divide by cosine of 20. Get rid of that. So now I have a value for T2 when I do my up equals down plus sine 20 T2 equals T3. Well, I'm going to put this right there. And then I'm going to solve for T2. And then I'm going to go back and solve for T1. So hopefully that will help you out. Okay, on to the next one. On to the next one. Hopefully I have enough spare paper here. All right, so this is chapter 5, number 6. Okay, and the first question is about a block at rest. They tell you how much force is required to start the motion, and then how much force is required to keep the motion. And you're asked to find the coefficients of friction. Starting the motion, that's going to be your static friction. Hopefully you got that, and that's going to be your kinetic. Kinetic friction is always smaller than static friction. Anyway, whoops, I'm off the page here, so let's try that. Okay, so I'll just slide this around just a little. Okie doke. So, use the values that you have in order to do that. Mu, of course, is the normal force, and the friction. Uh-oh, I think I hear the dogs. It's going to get wild in a hurry. I might have to do the third one as a separate video. Let's quickly do number 2. You've got your gal here. You've got theta. They tell you the mass of the suitcase, which means you'll be able to find Fg pretty quickly. And you're told what your tension is here, and you're told, uh-oh, I hear him. And here comes the friction, which is the number that they give you. Okay, so you're looking for your angle. Remember, left equals right. So Tx is going to be equal to 20 if you're moving with a constant velocity. And then you're asked for normal force. Remember again, up equals down. All right, Ty, normal force, Fg, you would add those together to find them. And so hopefully that will help you solve for that last one. Okay, so far so good. I guess we'll keep on going. Hey puppy. Oh, they're gonna eat, so I probably have just a few minutes before all manner of crazy breaks loose. So we'll see if we can't finish these last 2 problems up. Of course they're the toughest ones, right? Probably the ones you've been waiting on the video for. Okay, so here's our first one. You're given a value of P. You're told the mass of the block. That's good. That'll let you find Fg. And you're told the coefficient of static friction, and you're told the coefficient of kinetic friction. Okay, and then let's see what else. You're given an angle. Oh, that's good. All right, in my case, my angle is 20. All right, then you're asked to find things. Okay, assuming P is large enough to make the block move, find the acceleration of the block as a function of P. Okay, so you know you're not going to get a numerical answer. You're going to get a function for an answer. So that's not so bad. All right, we must have friction going this way. And of course, this is going to be P cosine of theta, and this is going to be P sine of theta right here. So it's our left-right that we're most concerned with, bigger minus smaller. Okay, and if it is moving, we can assume it's kinetic friction. Okay, so make sure you use your coefficient for the kinetic friction. Now, although you will not be able to come up with a numerical value for the normal force, which you need that normal force to do friction, not to worry. The p's are in there and it'll all work out. Okay, so just remember in the up-down situation, you've got p sine theta plus fg equals your normal force. Okay, so then you're going to, of course, when you do friction, that's going to be mu k times your normal force. Alrighty, be careful on your math. Watch the rounding. You're going out to the third decimal place. Okay, now B and C. You can do a whole lot of math for B, but let's take a quick look. All right, you notice that P is a small value and that in C, P is a much larger value. So here's the thing. If you don't overcome the static friction, then you don't accelerate. So if you want to avoid doing all that math, ask yourself, what would my acceleration be if I could not overcome the static friction? And try it. If it works, great, move on to the next part. If it doesn't, well, then you're going to have to do the math. But again, you're still doing really the same sort of thing right here. It's just that you know the value for P. If you are not accelerating, then remember that these two must be equal to each other, right? Otherwise, you're going to have unbalanced forces and you'd have acceleration. For part C, you'll notice it's much bigger. I can almost guarantee you're going to be accelerating there. So again, same thing, solve for acceleration now that you have the value for P, and find the value of your friction. Your value of friction is going to be with your kinetic friction because you will be in motion. Okay? Now, the last part of the question is probably the trickiest for many of you. All right, the minimum acceleration for when P is minimum and the motion is just ready to begin. Okay, keep in mind here, what we're talking about is we are just overcoming the static friction. So your friction is your maximum static friction. All right, so use your coefficient of friction for static friction to find what that value is, okay? And don't sweat it if you don't have a total answer quite right out of the gate. All right, but then plug it in and into your acceleration equation. All right, but remember you're moving at that point. You're using the static friction, that's your maximum, but you are moving, so you're still gonna work here. And then solve for your minimum acceleration. That should do the trick, I would hope. I should hope so. Okay, on to the next one. On to the next one. I can't believe I've gotten so lucky the dogs haven't figured out where I am yet. My puppy is usually all up in my grill in about 2 seconds. Okay, now this one might seem a little crazy. Oh, she's looking for me. I think I'm in trouble. All right, so you're given P and an angle here. Notice I'm putting my components in right away. That's kind of important. So you're given your angle of 50 degrees, and then you're given some values such as the mass of your block. Hey, baby girl, how you doing? She came down. You guys want to see this cute puppy? I'm sure you do. Here she is. There she is. She just came back from a walk. So and she got her dinner, so she should be ready to settle down. She just wanted to make sure that, all was well. Okay, so we know the coefficient of static friction that's given to you. In my case, here's my value for it. All right, let's make sure I can see. All right, good. So we're all back in the video. Okay, now you notice you're given maximums and minimums on this. Let me explain how this situation works. You've got gravity trying to pull you down, and you've got normal force perpendicular to your surface. And then it's like, well, where does the friction go? Well, you would think right away that the friction goes up here. And you know what? You would be right for part of the time. But you know what? If you push enough, you know that that's going to go sliding up the wall, in which case friction can switch directions and then go down. So that's where your maximums and minimums are coming into play. So when you are looking for your maximum possible values and things like that, what you're looking to see is that, well, up equals down, left equals right. If you do up equals down for a minimum, that's when friction's going to help you. So you're looking at, P sine theta plus Fs equals Fg. And then when you push so hard that you actually slide up the wall, well, friction flips around, all right, and goes the other way. So that'll allow you to find the values that you need, okay? Again, remember, you're gonna use your coefficient of friction to help you figure out your friction there, okay? Let's see, then you do it again with a different angle. Oh, that shouldn't be so tough. You should be all right there, okay? So hopefully that helps out. I'll be in the morning if you need more help than that, okay? All right, have a good night.